So now I've come to the last of the lectures in our series on solving exponential and logarithmic equations. And the last case that we're going to look at here is the situation where we have an exponential equation and the bases are different. Right? Remember in the case where the bases were the same, we were able to just set the exponents equal to each other. Well, we can't do that here. There's no way that I can manipulate 5 to, at least not easily, to rewrite it as 3 to a power. We've got the same problem on the other side. It's doable, but it gets weird, right? So here's how we're going to approach it. All I'm going to do is I'm going to take the logarithm of both sides of the equation. You know, the first question you got to ask me when I say take the logarithm of both sides is, well, the logarithm with what base? And the answer to that is theoretically, it doesn't matter. All right, you could do this with any base you like and get the right answer. When I'm doing this, I will often use the natural logarithm, the ln logarithm. And I'll tell you, honestly, the one and only reason I do it that way is because it's got fewer letters than any other logarithm. So, you know, it shaves a few seconds off of the time it takes me to do it. Another really good approach to this is to use one of the existing exponent bases as your logarithm base. Right, so I'm going to do this using the log base 5. You could just as easily have done this using the log base 3, right? And you would see the same little advantage that I'm going to get. All right, so let's do this. I'm going to take the log. I'm going to need a little room, so I'm going to go over to the left. I'm going to take the log base 5 of both sides. So the log base 5 of 5 to the x minus 1 equals the log base 5 of 3 to the x minus 2. Now, hopefully right off the bat, you can see why it was a good idea to pick 5. Okay, the log base 5 of 5 to the x minus 1 is just x minus 1. And the logarithms completely went away on that left-hand side, right? Which was nice. It's going to make the algebra manipulations we have to do in a minute here just, you know, that little bit easier. So on the right-hand side, I'm going to use that, again, that property that lets me bring the exponent out in front. So this becomes x minus 2 times the log base 5 of 3. Now, what I want you to really have firmly in your head at this point is that log base 5 of 3, it's a number. Yes, it's a weird number, but it's a number. All right, so I want you to think about the equation x minus 1 equals x minus 2 times 4. Right? How would you solve this? Well, you would distribute the 4 into the parentheses. You would move the x over and the numbers over and so forth. I'm going to do the exact same thing here. Right? First, I'm going to distribute that log base 5 of 3 into the parentheses. And this becomes x minus 1 equals x log base 5 of 3 minus 2 log base 5 of 3. Right, now I'm going to add 1 to both sides. The left side is x, the right side is x log base 5 of 3 plus 1 minus 2 log base 5 of 3. I'll talk in a minute about why I put that plus 1 in the middle. You could have put it over on the far right-hand side. There's a reason that I didn't, and I'll come back to that at the end here. Now I'm going to move this x log base 5 of 3 over to the left-hand side. X minus x log base 5 of 3 equals 1 minus 2 log base 5 of 3. Okay. Now those two things on the left-hand side, those are like terms, technically. And I really am going to kind of combine them together, but I think it's easier if you think of it as factoring out an x. Right, so if I factor out an x, this becomes x times 1 minus the log base 5 of 3 equals 1 minus 2 log base 5 of 3. And now we're there, right? One more step. This 1 minus log base 5 of 3, that's a number. Right? That's a number. It's a weird number, but it's a number. I'm going to divide both sides by it. and I'll get my final answer. And I'm just a little bit out of room, so I'm just going to jump over here to the left, to the right. And my answer is x equals 1 minus 2 log base 5 of 3 over 1 minus the log base 5 of 3. And that's it. That's my answer. Stop there. Perfectly good final result. All right. Resist the urge to first to try to combine those into a single logarithm. You cannot. And second, to convert this to decimal. Sure, you can, but unless the question specifically asked for a decimal answer, there's nothing wrong with that. And making that into a decimal is just going to be some messy calculator work, which increases the likelihood of making some silly little mistake, which is going to turn your answer from a right one into a wrong one. Leave it alone. That's a perfectly good place to stop. Okay, now a couple points about this. Jumping back over here, why did I insert this plus 1 in the middle? I just did it for clarity, right? If I had added it onto the end instead, this would have become x log base 5 of 3 minus 2 log base 5 of 3 plus 1. Now looking at this, I know what this meant. You probably know what you meant, but it's really easy as you're going along and you're focused on other things. You get 2 steps, 3 steps further down, and you see this 3 and the 1 next to each other, and you accidentally add them together when you shouldn't, because this 3 is part of this logarithm here, right? And logarithms are like square roots. You have to evaluate them first and then do things like addition and subtraction, right? So really your answer would be right either way. It's just I'm trying to head myself off from making a potential mistake, right? That's why I put the plus 1 in the middle. Now, what if you had chosen to do this taking the log base 3 of both sides, right, instead of the log base 5? You would have come up with a perfectly good answer. It wouldn't look quite like this. Obviously, there would be log base 3s in it, but it would be equivalent to it, right? And if you play some games with a change of base formula, right, changing these base 5 logarithms into base 3 logarithms, you can see that you get the same result. So in practical terms, if you're taking a class, and you're solving these equations, talk to your teacher, talk to your professor, whoever's teaching the class, and from them get what they want done, right? When you're watching, and you can kind of infer from if you're watching them doing things, in the classroom. Did they always take the logarithm of both sides, the natural logarithm, like the ln or the common logarithm? If that's what they do, then that's what I would do on a test, right? Or if they're doing what I did here, where they're taking one of the exponent bases as their logarithm base, then yeah, then you can go ahead and do that. And if they're doing that, then they should be aware that you'll get an answer that's visually different but equivalent if you pick either of the two bases.